All right. Hey, everyone. Welcome back to the Google Prodcast. This is Google's podcast about SRE and production software. Today, we have two special guests. We have Theo and Jeffrey. Jeffrey and Theo, why don't you guys introduce yourselves?
My name is Theo. I'm a site reliability engineer based out of New York City. And I've been working at Google for about 5.5 years now, specifically with Google Maps. And in the last 2 years, I've been working on this thing called STPA, which we'll talk quite a bit about in this episode. I'm super passionate about it. I used to be an STPA hater, but now I'm a convert, and I've been shouting STPA from the rooftops.
That's awesome. And I'm Jeffrey Snover. I'm a distinguished engineer. I've been working at Google 2.5 years. Before that, I was 23 years at Microsoft. And indeed, one of the things that drew me to Google was the opportunity to work on STPA and risk management.
Cool. And then we also have this other guy, Matt. I've met you before, I think. Have we met?
Yes, we have many times now.
Cool.
I'm Matt Siegler. I'm your co-host.
Okay, so STPA. Those are letters. Would someone like to unletter them for us? De-acronym them? Tell us what it really is. Like, even if the letters don't matter, what's going on?
I mean, STPA stands for Systems Theoretic Process Analysis. And what it really is a novel way of analyzing complex systems. So traditionally, when we look at outages, we think about the 5 whys, and we think about the sort of a time series of events that leads to some unacceptable outage. And when we think about the 5 whys, we say, okay, go back through the timeline, and then we find the 5th why, and that's the root cause. But systems theoretic process analysis takes a completely different view on hazards and losses. And what it says, it claims that accidents and losses happen when we lose control in the system. Some part of the system is misbehaving, and it's a control problem, not a failure problem. So I don't know if, Jeffrey, you want to take it from there.
Yeah, that's exactly correct. So this is grounded in safety design, came out of MIT. Again, all kind of grounded in this control theory, right? So that's MIT, right? So super good, and then lousy names. But that's exactly correct. And so, there are some circumstances where, there is no acceptable loss, right? Data privacy, data integrity, things like those. There, you really can't tolerate loss. If you think about it, when I talked to Ben Traynor about coming to Google, he said, Jeffrey, the heart of SRE is to manage this tension between reliability and innovation. And the way we did that was by coming up with this loss budget, right? The error budget. And what that says is, hey, we're going to define an error budget, and then you can go as fast as you want until you incur this amount of loss, and then you got to stop and then, reset. And that balances reliability, because he said, I know how to give you reliability. Get it working and cut off the check-ins. He said, but then you don't get any innovation.
Yeah.
He said, I can give you all the innovation you want as long as you don't want to have as long as you don't want to care whether it is up or not. And so basically the loss budget achieves that. He says, but the challenge is, how do we take SRE to the next level? How do we get this balance between reliability and innovation without the loss? And so that was the challenge he posed to me, to come to Google and work on that. So risk management was a big part of that. And then STPA is just a fantastic tool in the risk management toolbox.
Gotcha.
Yeah, I'd like to first talk a bit about what control means here. Tell me what you mean about control. That's a phrase that I think I know what that means, but I think you have a specific meaning in mind here.
Yeah, control is a really important term in STPA. When you think of a complex system, you have a bunch of different independent actors that are making actions in that system. So you can think of a human as a controller. Your computer is a controller in some sense. The environment is a controlled process. So when we talk about control, really we're talking about actions that constrain controlled processes. So an example of control might be something. So in the system, let's say of a thermostat in a room, I'm a human in a room with a thermostat and there's a boiler. As a human, I can control the temperature of the room via the thermostat, right? And that goes through the thermostat into the boiler, into the room. The room has no control over the temperature. It just is. I, as a human, have the most control in the system because I have the most agency. The thermostat has some control over the boiler, right? But the thermostat doesn't have control over me, right? It just has control over the boiler and transitively to the room. And the boiler controls the temperature of the room itself. So control is really about authority and the actions, right, that you can impose on the controlled processes.
Yeah, it is a different way to think about the problem, and it takes a little bit to, get your head through the knothole. That's why I think Theo mentioned he was originally an STPA hater. It takes a little like, what? But then you work through it a couple times, and then you're like, oh, I get it. And so, the heart of it is that this controller performs actions on a controlled process. Well, how does it do that? Well, first off, it has goals. Right? I want to be comfortable, right? So you got to know what your goals are. And then it has a worldview. So where do you get a worldview? Well, you get worldview from information, right? External information or information from the controlled process. And then you take that worldview, you compare it against your goals. If everything's aligned, happy days, you do nothing. But when the worldview is in conflict with your goals, then you have to do something. And you do something, which is to say you perform an action to make the world more aligned with your goals, right? So I'm cold, I look at the thermostat, no wonder, my damn kid set it too high, or whatever, too low. So I'm going to change it. So then I change it.
How different is this from like declarative versus imperative systems, right? You're kind of setting a goal, right? And then you're like letting the system do its work. Like we've talked publicly about like an annealing system that has been developed inside of Google and like the production world. And then also like in Kubernetes, we have these operators where we're setting some intent and then we're letting the operator, observe its system and, kind of collapse the wave function into something where, your intent becomes true. It seems like these are cousins, at least, or similar to each other. Is that right?
Yeah. I think the systems that you described can definitely be modeled in a control structure where these agents are controllers and they're very clearly attempting to control some underlying system. So it models control, but also feedback. And Jeffrey was describing that feedback. And you were also describing that feedback, Steve, about observing, right? So you have an intent, right? And you observe the production system and you're saying, the production system is not in the state that I want it to be in. Okay, so you're observing, that's feedback. And then you process that feedback and then you execute an action. And so that's the feedback. There's a control and feedback loop. Now the problem there are problems that can occur when some part of that loop breaks. Okay? Either I misinterpret the feedback. I believe. So for example, the production environment is in a bad state. Let's say we're having a complete outage, okay, because we have the wrong binary release. My system that processes the production environment incorrectly observes my production environment. And it says, I have the correct binary in production. And therefore, it does not issue an action. The result of that is that my outage persists, even though I have told my production manager to remove any binary that is quote unquote bad, right? So that's an example of it being unable to interpret the feedback correctly, and as a result, letting an outage persist. So these feedback loops are really important, and that's really at the core of STPA, is modeling these control and feedback loops, and then identifying the conditions under which these control and feedback loops misbehave, and as a result, achieve an unacceptable loss. And when I say unacceptable loss, what I mean here is, we have a loss of revenue, or our lawyers get upset, or XYZ problem that maybe I can't talk about on this podcast, right? Something that is truly unacceptable. And we try to figure out the ways in which this system might result in that unacceptable loss.
Now, Steve, I want to go back to your example because you actually produced a perfect example to highlight two of the critical aspects of STPA. So you said, hey, what's the difference between, basically a desired state controller, where you set things and it goes, versus an operations-oriented model? Well, they're both controlled processes, and they're two patterns for controlled processes. One is where the human gathers the information, compares it against things, and then you perform the control actions. The other is where you say, hey, I express my intent, and then the system does that loop. And then those are two different models. Both work with STPA. They have strengths and weaknesses. But one of the great benefits of STPA is that it is a system that allows you to analyze things that are socio-technical, which is to say some of those decisions are made by the system and some of them are made by you. So for instance, even the case of desired state configuration, you made the configuration. What was your process for doing that? And often that has controls and is informed by systems, etc. And it is often the source of error. Like, oh, the system worked perfectly. I just gave it the bad configuration.
Are you suggesting humans are fallible, Jeffrey? How dare you, sir?
It turns out.
I'm following you here. It feels like this is a bit theoretical, but I'm feeling us getting towards something practical pretty soon here. We're gonna do some modeling here, where you're modeling the behavior of something that maybe traditionally we had some implicit belief in how it behaves. We're gonna model it a little deeper than we used to. We're gonna model these losses differently in a different way. What is this gonna buy us? Why would we go to this trouble? Because it sounds like there's gonna be some trouble. I'm gonna get some payoff. Why am I headed in this direction? Presumably because of a payoff. Tell us a little bit about that.
Yeah, so that's a really great point. Ultimately, everything comes down to cost and benefit, right? And as site reliability engineers, my benefit is making sure that our systems are safer. Now, what tools do I have in my toolbox to figure out whether or not a system is safe? Well, I can do design reviews, I can do code reviews, I can implement N+2 redundancies, right? I can implement SLOs, but none of these really get at the core benefit of understanding whether my system is safe, right? I don't really, in my design review, I try and really go down this random walk of all these possible edge cases, right? I don't have the framework through which to systematically review the safety of my system. And STPA, and this was a process that took us a long time to get right with software, but STPA allows us to very efficiently identify key design flaws before we've even written our code. So I'll give you an example. I ran an STPA on a system that had not yet been built. All right, it processes road disruptions, takes as input information from the world, and it figures out which roads should be closed on Google Maps. And this design seemed really simple. Read a file, figure out what's changed, write it to a database. Couldn't get simpler than that. How hard could it be? How hard could it be?
I can do that. Come on.
What could go wrong?
What could go wrong? Now, we look at this design, and everyone looks at this design and gives us a thumbs up. Let's launch. And then I said, hold on, there's this new thing called STPA. And it allows us to analyze designs that are relatively, we'd think this might be simple, but, there are a few steps in here. Let's analyze this. And give me, and I tell this to my developers, and I say, give me an hour and a half of your time, and let's run STPA on it. And let's see if we can catch any design flaws. And if we catch a few, maybe you'll want more of this STPA.
This feels a little bit like formal methods. Is this kind of like where you look back at your system and you define the algorithm in TLA or something, and you run a checker against it, and you're like, Is it that level of system, or is it totally different? Am I getting that wrong?
Well, that's a great question, and it actually comes up a lot. People ask, "Oh, like I've used TLA plus, and this is not like TLA plus.
This is not that. Okay,
this is not that.
TLA is hard. I don't want to do TLA.
And I think STPA is hard to get right, but it's hard for a different reason. It's not tedious, right? And you aren't trying to exhaustively define the behavior. Actually, you look at the abstract responsibilities of all of the different parts of your system. And so what we did is we spent an hour and a half with these developers of this road disruptions pipeline. And we found something like 3 system gaps in an hour and a half.
Can you describe any of those in particular? Like what's the detail? Like, is it like they forgot a semicolon, or is it something more fun than that?
No, it's a key. It's like a fundamental like requirements gap. Okay. So the one that I give in my talk is the one where essentially the impact of this gap is that we have a logical flaw. Okay, the result of it is that we forget to add road closures onto the map. All right, so imagine this. Okay, you have a parade in New York City, and we've known about this parade for months, and we could have added the road closure, across Brooklyn, and yet for some reason we don't add the road closure onto Google Maps. And we navigate users across that parade. So now you have a backup of cars trying to cross a parade.
No bueno.
That is, and then we have this mega PR event. So that's the loss. All right. Okay. So then the question
seems bad. Got it. Yeah, for sure. Yeah.
We don't want that.
Yeah.
So how can this system result in that loss?
Right.
That is the question of STPA. All right, we try to answer that question.
Presumably, you did not a priori say, let's not have active roads cross parades somewhere. That didn't go into the analysis ahead of time.
No.
So how did you discover losses without being so specific ahead of time?
The loss is we send users down a street that has a parade. All right, concretely what that means is we don't have a road closure in our database on Google Maps, where there should be a road closure. All right, so there's a missing road closure in our database. So you ask yourself, and now I'm going to be paraphrasing a lot of the mechanics of STPA here, but essentially we say, well, how on earth could that happen? How on earth could it be that we don't add a road closure when we should be? So we have in our control structure, the bottom part of our control structure is our database. That is the system that we're controlling. And we have a controller, which is another piece of software, whose goal is to ensure that all active road closures are on Google Maps. And so it has a control action of add a road closure or remove a road closure. And so then the question is, how could it be that we don't add a road closure when we should have? Now, that's the question. And then we look at the feedback, we look at the control actions, we look at the logic inside of that controller. And in this particular case, we discovered that the logic inside of this piece of software was flawed. So, how on earth did this piece of software figure out when to add a road closure? Well, let's look into it. What it did, gets a file, all right? And the file contains all active road closures. And then it gets another file, and that's version 2. And what it does is very simple. It diffs the 2 files, and it says, aha, here's a new road closure in version 2. Let me add it into Google Maps. But what happens if, when in the process of adding this road closure, it fails to do so?
Oh, like the diff just doesn't diff or something like that. Like
the diff doesn't diff, or maybe the
or it's a crash
HTTP request.
Yeah,
exactly.
No
the
retry.
HTTP request fails. No retry.
Anything.
Or maybe there's a maximum set of retries and it fails all 3 retries.
Yeah.
All right. You see where this is going?
I have a guess. Yeah.
Version 3 is compared against version 2. No diff.
Yeah. should be fine.
Should be fine.
Parade away. Have a parade.
Parade away. Exactly. Well, according to Google, there is no parade. And so the flaw here is in assuming that the previous version of this file is equivalent to the state of Google Maps. Now, if you were to look at this from a data flow diagram, right, you would say, oh, of course, you just diff and then you apply. And if you fail, you reapply. Right? Or even if you don't think about failure, I mean, that's sometimes the case where we don't think about this edge case. And this is not, I'm not trying to disparage anyone, really. This is the number of states that you have to think through in order to exhaustively identify all of the failure modes is enormous. I mean, it's 2 to the n, right? Where n is the number of parts in your state. So with STPA, you start from this top abstract view, okay? Here is the unacceptable loss. And then you dive a little bit deeper and you say, how could this happen? And then you dive a little bit deeper and you say, okay, it must be this control action that could possibly lead to this loss. And then you ask another question. Okay, so under which conditions could this control action be unsafe? And then you might even dive a little bit deeper if you'd like, and then see that your diffing logic is flawed. And that is an example of one case, right, where you lead to the loss.
This is a great, I'm really happy this is like a concrete example because I've never heard one before. I've heard STPA so many times and they've been like, it's clearly a matter of risks and rewards and P's and A's and something like that. I'm like, yeah, but what is it really? Okay, so this is great. So my first question or the thing in the back of my head is like, when you went to go to analyze this, you had to use your, smart human brain to come up with that high level abstract risk of, I don't want cars to cross road closures, right? That was the thing that drove the rest of this analysis. Is that right?
Yes.
Okay. So the step one is thinking about the abstract, unsafe behavior of a system, the losses. Thank you. That's the term. And then you go through this process of figuring out what could then drive those losses to occur in reality. Does that sound about right?
That's exactly right.
I think we got it. Matt, I think we're done.
Well, let's
call it.
Can we talk a bit about the relative concern of different kinds of losses? 'Cause
yeah.
You can have very unusual losses like, rock falls out of the sky and causes a damage to the road, and that's a surprise, but that's probably happens almost never, but it does happen. Then you have a parade, which is rare, but does happen once in a while. And then you have a traffic jam, which happens every day. Like, I'm going to guess there's some probability entering into this. Do we have some of those things happening in there?
That's an interesting question. And in the world of systems safety, probability is a hot topic. And depending on who you ask, someone might get upset that we brought up probability, in part because it is actually very hard, unless you have many, many samples, right? It is actually very hard to provide an accurate probability. And so what we've been trying to do, at least within Google Maps SRE, is by using a different metric to prioritize losses and mitigations. So really across all losses, there is every loss is unacceptable. So, some may be more unacceptable than others, but truly we don't want any of them to happen by definition. Then when we look at ranking loss scenarios, we think about the number of ways that a loss scenario can occur. And then actually what is more important, I think, is the cost of the mitigation. So how costly will it be for us to prevent this loss? Maybe we can, for 20% of the cost, we can get rid of 80% of the problems, right? And that's really just the cost benefit where we start horse trading, right?
And it's important at this point to draw the distinction here. And now we're talking about a set of things that deviates from the MIT STPA approach, right?
Okay.
So from them, they're sort of absolutists, right? Hey, this is used for the design of a nuclear plant. This is used for an aircraft carrier. And for that, you got to solve all of them. It doesn't really work for our world. So we have had to take STPA in its pure form and then kind of say, hey, in a world of commercial software development, you need to make some changes. And so Google's been leading that way. We've been documenting those things. Theo and others have been giving talks about how you take this great technology, but then you apply it in the real world for software systems and to be effective.
Yeah, I was going to say that in the software world, everything is possible.
Everything's possible, baby.
Yep. Now, to go back to this Pareto point, what we end up doing within Google is actually performing at 20% of an STPA. We rarely have the time to complete an STPA, and usually it's because we find so much at the 20% mark, right? So to complete this road disruption story, we found 3 problems within an hour and a half, and the developer said, more please, let's do another session. And so we did another session, and overall, we spent about 27 hours across 5 engineers, and we found 7 design flaws. 7 design flaws. And this is 27 SWE hours. Now, these 27 hours included the cost of fixing these problems, which was so cheap because we hadn't built the system yet. It's a super efficient design review. And we were able to solve these design flaws by rewriting the design document. Mm-hmm. And we only analyzed, I would say, 20% of the control structure in order to find these 7 design flaws.
This sounds a little bit like test-driven development when you're at the engineering point, but upstream a bit at the design point. How thorough do I need to be in my design before STPA can be useful? Because lots of designs are not particularly thorough. They're not deep into their trees of all the different states you could get at. When can you show up and actually apply this? Like, I haven't figured out all my edge cases yet. I'm on iteration 2 of 5,000. When can I get to STPA? Like, how mature do I need to be?
So the good news is that you can use STPA before you've actually designed your system. We have started experimenting internally, and it has been done outside of Google already, but we've been using this internally where we use STPA to design our system. We start with the control structures, and we define the goal of the system that we want to build, and we think, okay, in the abstract, okay, what controllers do we need to make sure that these losses cannot be achieved? And then we say, okay, we need this abstract controller to constrain this process. We need some system to ensure that our database is never in this state. And then once we've defined these safety requirements, we can then go to the paper and say, how do we build that? And here are these safety requirements.
What we found a lot is these feedback mechanisms are broken. Second biggest thing, go and say, hey, what's the goals of the system? Mm-hmm. Silence. It's like, wait, no, I'm just asking, like, what's it supposed to do? Silence.
A lot of implicit goals.
Yeah.
Or sometimes we don't even realize what we're trying to achieve.
Yeah, that's the point. And so, again, back to how STPA can be helpful, you got to start with, what are your goals? What does success look like? And then from there, you say, okay, what does loss look like? And then that can guide your designs and decisions.
So it sounds to me like STPA is not a compiler. It is not a system that looks at a system and goes like, here's 16 errors. It's a discussion technique. Like, it's a human to human conversation over some hours on a whiteboard and a lot of coffee, probably, like Red Bulls.
That's entirely correct.
Cool.
It is a human-driven process, mm-hmm. and in some ways, it's a question prompting engine, is what I think of. STPA.
And
yes.
since we're talking to an SRE audience, a lot of people will say, well, hey, how's this compare to reliability? So Theo, you've got a great example of the difference between reliability and safety. Have at it, my friend.
Thanks for setting me up on this one. I have a prop. I do have a prop for this. So the difference between reliability and system safety can be conveyed with the butter knife. Now, the butter knife is a reliable component, right? I mean, I can't break it, and I'm really putting in all my energy, and this is a good Google knife, not branded Google, but it came from it. Property of Google. Thank goodness I can't break it. And it can perform its responsibilities well, and I can cut butter with it, and I can do so safely. I won't get hurt by using it to cut butter. But what if I took this butter knife and I shoved it in the electrical outlet? Okay? I'm going to be electrocuted.
For the audio-only audience, Theo showed an outlet and put it. That was uncomfortably close to the outlet, man.
Too
Come
close.
on.
I know.
Yeah.
I apologize.
You've practiced that move.
I have, yeah. More than once, actually.
So this system you're describing is unsafe despite it having reliable components. Is that what you're kind of saying?
Exactly.
Yeah.
The electricity. So the outlet's goal is to provide electricity.
It's very good at
Knife's
that.
goal, it's very good at that. It's very reliable.
Yes.
The knife is to remain a knife and to be metallic, and it just so happens to be conductive. All right. And I'm also reliable. I'm reliably curious, and I do wonder what happens if I shove a knife in an outlet. And as a result, I achieve a loss because I am irreparably damaged.
I love it.
And this highlights, again, one of the great elements of STPA, the thing that differentiates it from a lot of other technologies and approaches, and that is STPA is great at finding flosses for every component of the system works reliably and as intended. But the system produces devastating losses. And STPA is the only mechanism that I know that provides the context for finding those systems. In fact, the 737 MAX system, that was an example. All the components of that system worked as designed, worked reliably, but there were unexpected interactions between those systems that then resulted in a terrible and devastating loss. So again, one of the things you get out of STPA that you don't get out of anything else.
Can I show you a book? Do you guys like this book?
Thinking in
Systems by Donella Meadows. Yeah. This is one I like. I think it's a good introduction to this type of thing. There's also like Systematics is another good one. That's a little bit more technical. Or Systemantics, I think it's kind of an older book. But like if people haven't looked at the books around systems thinking in general, I highly recommend it. Like for whether you're going to stamp or not stamp, like just SREs in general, I think like looking at this type of ways of thinking about components versus systems is super, super imperative.
100%. And just one thing on that, I am so grateful that I learned about STPA, not only because it helps me in my work at Google, but also because now I see the world in systems.
Can't unsee. That's right.
And it's completely changed my worldview. So I would highly recommend learning about systems theory. At MIT, they've used STPA to model all sorts of social systems, and they've found flaws, right? Mm-hmm. So it doesn't just apply to...
Who could have seen that coming?
Believe it or not. Believe it or not. So it doesn't just apply to technical systems. It can apply to any system in the world.
Yeah.
I feel like I understand this way better than I did before.
Yeah. Hey. Our job
Amazing.
is done.
Success. Matt, do you have any further questions?
Where would you like to see bigger picture here, this go? So with the SRE book, we got people to use these practices in their daily work, like actually build tools, use these things in production. presumably there's a corollary set of principles using in design. Like people will actually have templates off the shelf practices that are analogous to what we're just talking about here, that they'll be doing them in design reviews, and it'll be, second nature, and won't be some set of experts to come and descend and then find 7 really terrible things about the thing they just designed, like you just described. But it'll be like just, two, engineer A, engineer B, product manager go look at a thing and go, oh, yep, that won't do that. What would you like to see happen that's just normal business as usual by learning some of these things?
Yeah, I think that you've got it exactly correct. That there will be practices and techniques and, hey, when do you apply it, et cetera. Now, again, people can go look up STPA or STAMP at MIT, and you'll get really thick books, and they're great. They're fantastic. But when you go to try and apply it, it's going to be kind of tough. I really would encourage you. Google has produced a set of work that people can, I would encourage you to start with that, honestly. We're leading the way, bringing these practices to services, bringing them to software, producing the content to do that. Theo has a number of, Ben Traynor, again, inventor of SRE, and Tim Falzone, one of our STPA facilitators, wrote a great blog talking about STPA as the future of SRE. And then, Theo, you want to point to the number of the other?
Yeah, so I gave a talk at SRECon this past spring where I dove into more detail about this road disruptions system, and I used the knife there as well, so that's a great primer. And at MIT, there is a bi-yearly conference where you can learn more about STPA and STAMP, and those are free. And stay tuned, because I think we'll be releasing more content about STPA to the community.
And the MIT conference, a number of the videos from those are online. And again, I encourage you to watch the ones from Google, because the others are great as well. But we go into the details of how do you roll STPA out to a community? How do you know when to go this far, but not far, that far? Things like that.
Okay. Well, thanks very much, guys. Like I said, I feel like I actually understand it this time, which is fantastic, because it's not the first time I've heard about it. And it's like, I feel like it's working. This is great.
It's going to stick.
It's going to stick this time.
Definitely,
finally.
It's one of those
this is the one.
new things. You got to get your head through the knot hole.
Totally.
And then once you're through the knot hole, because that be a difficult transition. But then on the other side, you're like, oh, wow. I wish I had known about this before.
Right. Well, where can our listeners hear more from you, both of you, and about this program? Like, do you have any final send-offs, like, follow-up notes? Where should people keep going for this journey?
Yep. Okay, so I'm on Twitter at @jsnover. I'm also on Blue Sky at jsnover.com.
And I don't have a Twitter or a Blue Sky, but maybe I should. But you can find me on LinkedIn, Pierre Theo Klein. I have a second first name, Pierre, spelled Pierre, Theo Klein, otherwise known as Theo. And
we'll get it right
that's
eventually.
Primarily where you can find me on LinkedIn.
Cool.
And then otherwise for STPA, check out our blog posts and check out MIT Stamp.
Awesome. Thanks very much, guys. This was awesome.
Super duper.
Yeah, thanks for having us.
Till next time. So long, folks.
Adios.
You missed a page from Telebot.